Okay, in this very last part of lecture 13, we'll do our little baby story problems, and we're going to solve these using substitution. Okay, so let's say that we have the difference between two positive numbers is 26. The larger number is 3 times the smaller. Find the numbers. Now remember, for your story problems, I've begged you that the first thing you'll do is make a key. I know this is an easy problem, but just humor me. Let's make a key and say, okay, my larger number is x, my smaller number is y. Now this is just a translation problem. It's really no different than the translation problems that you did in chapter 2, except now we have two things that we don't know, so we have two variables. So let's look at this. The difference between two positive numbers is 26. Difference, what does difference mean? Difference means subtraction. So the difference between two positive numbers, that's going to be x minus y, is 26, that's equals 26. So my first equation is x minus y equals 26. Okay, see if you can get the second one on your own. Pause me. All right, second one. The larger number. Which one's the larger number? What do I write down? X. Okay, good. X. The larger number is. Is means equals, so I have x equals 3 times the smaller, 3y. Perfect. So now we're just back to exactly what we've been doing over and over and over again. We're going to do substitution. Look at those two equations and make sure that they make sense. And now, for substitution, the first thing I want to do is get one variable by itself, which I've already done. I have x equals 3y. So I plug that into the other equation. 3y minus y equals 26. So it's 2y equals 26, or y equals 13. Back substitute where I had x by itself, and x equals 39. Hopefully you don't think that's too hard. The story problems will get a lot more involved in lecture 15. So hurry and get really good at these ones right now. So my numbers are 13 and 39. One more story problem. Two angles are complementary. Okay, stop. What does complementary mean? Complementary starts with a C, so I'm talking about two angles that make a corner. Two angles that when I add them together give me 90 degrees. Okay, so for your key you might want to draw that. One angle is 1 degree less than 6 times the other. Find the angles. So angle 1 is x, angle 2 is y. I know x plus y equals 90, and x equals 6y minus 1. One angle is x equals 1 degree less than, I'm going to subtract 1 from something, 1 degree less than 6 times the other. That gives me my 6y. Step 1 for substitution is get one variable by itself, which I've already got, luckily. Plug it into the other equation. So I have 6y minus 1 plus y equals 90. 7y minus 1 equals 90. 7y is 91, so y is 13 again. And back substitute for x. X is 77. So my angles are 13 degrees and 77 degrees. So just kind of a quick review. If you're solving a system of equations by graphing, step 1, get both the lines in slope-intercept form. Identify the slope and y-intercept. Graph them really carefully. Find where they cross. Check your answer by plugging it into both equations. If you're doing substitution, pick one variable to solve for and pick a good one. Substitute it into the other equation. Solve for one variable, back substitute, solve for the other variable, and again, check your answer by plugging it into both equations. The things that could happen, if you have one solution, when you're graphing it, your lines are going to have different slopes, so the lines will only cross once. That'll be easy. If you're doing substitution or elimination, you're just going to get an answer. Again, elimination is what we can't cover next time. If there's no solution, for graphing, you have the same slope but different y-intercepts. That means the lines are parallel. If you're doing substitution or elimination, all variables will cancel while you're solving, and the remaining statement will be false. To get an infinite number of solutions, if you're graphing, your lines are going to coincide. They'll have the same slope and the same y-intercept. If you're doing substitution or elimination, all variables will cancel while you're solving, but what is left is true. That says your lines cross when 5 equals 5 or something, which is always so your lines are coinciding. All right, that is the end of lecture 13, and I will see you for lecture 14.